Today's problem, cutting binary string, difficulty medium. You are given a binary string S consisting only of characters 0 and 1. Your task is to split this string into the minimum number of non-empty substrings such that each substring represents a power of 5 in decimal. For example, 1, 5, 25, 125. Don't forget the 1. I missed that the first time I tried this. It didn't occur to me that 1 would be considered a power of 5. I mean, it is, like 5 to the 0. But anyway, if you miss the 1, it's not going to work for you. No substring should have leading zeros. Return the minimum number of such pieces the string can be divided into. If it's not possible to split the string this way, return -1. All right, so here's an example. Now 101 is 5. 101 in binary is 5 in decimal, which is the power of 5. And we can split that, and we can split it. Actually, there are 3 101s here, so we can split it like this: 101, 101, 101, each of which is a power of 5, no leading zeros, and that's 3 pieces. This string here, as it happens, is 125, just the way it is. So we don't need to do anything. It's just, we need to do something, but we don't need to split it, so the output is 1. S here is a bunch of zeros. All right, that isn't going to split into powers of 5, so we return -1. All right, size of the string is between 1 and 30. Expected complexities, O of n squared. Yeah, we're going to do it with a nested loop. So it's n squared, but if the string size doesn't go above 30, then n squared doesn't pose any problem. Company tags, Flipkart, Walmart, Google. Flipkart, I see Flipkart more than anything on here. Topic tags, dynamic programming, and bit magic. I don't think we're going to do anything that I would consider bit magic. Dynamic programming, yes. Let's walk through an example of this. We can use the first one here as an example. All right. In some problems, it's helpful to do some pre-computation. Possibly with a prefix string. I mean, in this case, it's going to be useful to pre-compute powers of 5 so that we don't have to compute powers of 5 over and over and over again every time we get, a new binary string, convert it to decimal, and see if it's a power of 5. We're not going to do that. So what we're going to do instead is create a set. We'll start with, wait a second. 1. We're going to start with 1. We're going to put 1 in the set, and then we're going to multiply it times 5. And we're going to put that in the set. And we're going to keep multiplying it times 5 as long as it is less than 2 to the 30th. Why 2 to the 30th? Because that's the maximum size of the string. So any power of 5 that's greater than 2 to the 30th is of no interest to us. All right. Get the string length. We got a DP array here of n plus 1. We are going to we're going to use like 0 to n. We are going to fill the array with n plus 1. Really, that's just an indicator what do I want to say about that? It is helpful in solving the problem, but it's also an indicator as to whether or not we solved the problem. So let's let me scoot this up so I get a little more white space. And actually, let me move this. Let me move this over, and let me move this over. I still want to be able to see everything, right? Yeah, that's fine. All right, so let's create this array, and the number that we're going to be using. Let me get a pen. Let's see. Let me make the array first, and we're going to fill it with n plus 1. Now, n in this case, the length of the string is 9, so we're going to fill the array with tens. So we're going to need 10 tens. Is that right? Yes. You know what? Let me pause this instead of just writing 10 tens in real time. Okay, top row. This is the DP array. This is the string. Right here, dpn equals 0. That really represents an empty string. We're not going to get an empty string. It's guaranteed to be between 1 and 30. But we need it really as a base case to start the dynamic programming. So, and we're going to be processing this backwards. So I is going to start at n minus 1. And then in the inner loop, j is going to go from I to n. So let's start it like this. I is going to be here. J is going to be, j is also going to be here. We're going to get that number. What is that number? It's 1. And then we're going to say, does power of 5 contain that number? And in fact, it does. So dp at I is going to be the min of dp at I, which is currently 10, or 1 plus dp at j plus 1. Now j plus 1 is going to be here. So we will add 1 to 0 and set this to 1. All right, that's gone. And this is now 1. So we could split this if that was the, we could split this as a length of 1. Okay. Next, I is going to be here. Now, the first thing we do every time we increment I is check and see if I equals 0, because we can't process numbers with leading 0. So if it is a 0, which it is in this case, we're just going to continue. We're going to continue to this number. All right, now we're going to start moving from j. J will be here, and we'll look at this and say, is this a power of 5? And it is. So the dp here is going to be the min of 10, or dp at j plus 1. J is still here, so dp at j plus 1 is here. So this is going to stay at 10. That isn't going to change anything yet. All right, we'll move j to here. This string from I to j is not a power of 5, so we're going to move j to here. Now that is a power of 5. So now dpi is going to equal math min of dpi, or dp at j plus 1 plus 1. Now dp at j plus 1 is 0, and add 1, so we are going to change that to 1. All right, so this is no longer a 10, this is a 1. Okay. So again, we could split this from here, and that's one one piece. All right, now I goes to here. Is that a power? I is here and j is here. Is that a power of 5? Yes. So dp at I is equal to math min of 10 or 1 plus dpj plus 1. Now j is here, so dp of j plus 1 is here. If we add 1 to it, it's 2. And 2 is less than 10, so I'm going to take that and remove it and replace it with the 2. So that looks good so far, because really if this was the only string that we had, it would be, the answer would be 2. We could split off the 101 and then we could split the 1. Okay, let's go the rest of the way here. That is not a power of that is not a power of 5. That is not a power of 5. That is not a power of 5. All right, so I goes here. But we're going to ignore that because it's a 0. Now I is going to go here. I and j are both here. This is a power of 5. So dp at I is going to equal the minimum of the current dp at I, which is 10, or 1 plus dpj plus 1. No, so that isn't going to work. dpj plus 1 is 10. Okay. So we'll keep going. 1. We're moving the j now. 1, 0, is that a power of 5? No. 1, 0, 1, is that a power of 5? Yes. All right, so now j is here. We've got a power of 5, so the dp at I is going to be the min of 10 or 1 plus dp at j plus 1. All right, j plus 1, dp at j plus 1 is right here. If we add 1, it's 2. So this is going to be replaced by a 2. Let's take that off. And replace it with a 2. Okay, it's probably not going to surprise you. And actually, you know what? I don't know that we need to work through the rest of this, because the same thing is going to happen for this 101. This will change to a 3, and when we get here and we run through the 101, this will also change to a 3. And so then what do we do? We're going to look here after we get through the loop and say, does dp at 0, which is here, does, oh, I'm sorry, well, it's here. Does dp at 0 equal n plus 1? In other words, what we initialized it to. And if it does, it means we were not able to get through that string and split it into powers of 5. So if it's still n plus 1, we're going to return -1. Otherwise, we're going to return whatever is in dp0, which is 3. And 3 in this case is the correct answer. So let's try running this. I'm going to move this back over here. All right. Submit. Okay. 2 out of 3. 2 out of 3. Yeah. The first one is one I didn't realize the 1 was a power of 5, so that was a mishit. Okay, key takeaways would be pre-computing the powers of 5 and the dynamic programming technique. And that's it. Give the video a like, subscribe. You'll get problems of the day in your inbox, and we'll see you next time.